Hello, good day to each and everyone. So I am Farah Batingalo, and for today's presentation, I'll be presenting my output in the activity 4 entitled Factors Affecting Solubility. So without further ado, let's begin. But before that, let me state first my objectives for today's presentation. The first one is to understand the factors affecting solubility. The second one is to define solubility. And the third one is to discuss the factors of dissolving. Solubility. Whether or not a solute will dissolve in a solvent and the extent in which it will dissolve. The amount of a solute will dissolve in a specific solvent given condition. So here are some of the factors that affect solubility. The first one is the nature of the solute and solvent. The second one is the temperature. And the third one is the pressure, only applicable to gases. Nature of solute and solvent. Remember covalent and ionic? Polar solvent, a liquid made up of polar molecules. Nonpolar solvent, a liquid made up of nonpolar molecules. When two substances are similar, they can dissolve in each other. Polar solutes dissolve in polar solvents. Nonpolar solutes tend to dissolve in nonpolar solvents. Like dissolves like. Two liquids dissolve in each other because their molecules are alike in polarity. The second factor is temperature. Solutions of gases and liquids are affected by temperature. As temperature increases, the solubility of gas in liquid decreases. Why? As the temperature increases, the kinetic energy of the solute gas increases and the gas can escape. Solubility of solids in liquids, total opposite. The solubility of solid increases as the temperature increases. There are a few exceptions. Temperature affecting the solubility as the solution is formed. When the temperature drops while you mix the solute and solvent, raising the temperature will increase solubility. If the temperature stays neutral, the temperature will have minimal or insignificant effect either way. If the temperature is increased when the solute and solvent are mixed, raising the temperature will decrease solubility. The last factor is the pressure. When the pressure is increased over the solvent, the solubility of the gas is increased. Why? Pressure increases as gas molecules strike the surface to enter solution is increased. Henry's law, solubility of gas is directly proportional to the partial pressure of the gas above the liquid. Factors of dissolving. Rate of which a solid solute dissolves in a solution depends on three factors: surface area, stirring, and temperature. The rate of dissolving is unrelated to the solubility if the solutes dissolve quickly or slowly does not alter or depend on its solubility. Surface area. Dissolving solutes happens in the surface area of the solvent. Speed up the process by increasing the surface area. The greater the surface area per unit mass, the quicker it will dissolve. The second to the last is the stirring. Dissolving happens on the surface of the solvent. Contact between the solvent and the solute is increased. The last but not the least, temperature. Raising the temperature increases the rate of which a solute dissolves. Solvent particles move faster as they come in contact more with the solute. So I'll be showing to you the materials. First is disposable cup. Second one is the dropper. Third is the Zonrox or disinfectant. Alcohol. Ink. And also cooking oil, and also a gasoline. First procedure, set up 3 containers, transparent bottle glass. Place 5 drops of cooking oil into each tube. After that, add 10 drops of water to the first container. Then after, 10 drops of alcohol into the second container. Then add 10 drops gasoline to the third container. Shake each container vigorously and record your observations. Observation Cup 1: Cooking oil and water. Oils based contrast are non-polar, and as a result, they're not attracted to the polarity of water molecules. In fact, oils are hydrophobic or water-fearing. Instead of being attracted to water molecules, oil molecules are repelled by them. As a result, when you add oil to a cup of water, the two don't mix with each other. Because oil is less dense than water, it will always float on top of water, creating a surface layer of oil. Observation in Cup 2: Cooking oil and alcohol. Since oil floats on top of water, you might have thought that oil would float on top of alcohol too, but the oil sinks to the bottom and alcohol floats on top of the oil. Even though water and alcohol are both clear liquids, they have different densities. Alcohol floats on top of oil because a drop of alcohol is lighter than a drop of oil the same size. Observation Cup 3: Cooking oil and gasoline. Gasoline contains many different non-polar substances such as hexane, heptane, and octane. Gasoline effectively dissolves oil and even grease. Repeat Procedure 1: Birthplace Cooking oil with Zonrox disinfectant. Make sure the amount of disinfectant used are almost equal. Observation Cup 1: Zonrox disinfectant and water. By mixing different amounts of bleach with water, you can make a high, intermediate, or low-level disinfectant. It dissolves well. Observation Cup 2: Disinfectant and alcohol. By mixing the two, we can see that the Zonrox and the alcohol dissolves well. Observation Cup 3: Zonrox or disinfectant and gasoline. By mixing the two, we can see that the Zonrox and the gasoline doesn't dissolve well. And the last thing that we will do is to repeat Procedure 2 using tincture of iodine or ink or dye. Observation Cup 1, ink and water. We can see in the video that mixing these two liquids properly dissolves. The water and the ink dissolves well. Observation Cup 2, ink and alcohol. When two chemicals of similar chemical structure like ink and alcohol, they mix together well, which is another way of saying one easily dissolves the other. When getting an ink stain out, the alcohol dissolves the ink off a fabric or your skin or a tabletop, allowing you to easily wash it off. Observation Cup 3, ink and gasoline. When gasoline and ink are combined, they do not mix evenly, but instead form two separate layers. Each of the layer is called a phase. So for generalization, the solubility, the behavior of an organic compound is affected by the temperature, its surface area, and nature of solute and solvent. This is used to identify the structure of an unknown compound. Some personal errors may encounter when experimenting. Upon shaking, this can be avoided by shaking the test tube vigorously. When a liquid unknown seems to have dissolved in the liquid, the solution will become cloudy if two phases are present. So that would be all. Thank you for listening, guys, and I hope that you learned something from me. See you in the next video. So another factor that affects solubility is temperature. So in this video, I will show you how temperature affects solubility. So I set two containers here, and the first container contains cold water and the second container contains a hot water. So as you can see, in hot water, mas dali siya na dissolve compare sa cold water. So for observation, when water is heated, the molecules gain energy and thus move faster. As they move faster, they come into contact with the powder more often, causing it to dissolve faster. So this is the reason why in the cold water, the powder dissolves slower. It is because there is a greater difference in the rate of dissolving, because there is a greater difference in temperature between hot and room temperature water, about 30 degrees, than between room temperature and cold water, about 15 degrees. So for generalization, increasing the temperature generally increases the solubilities of substances. As the temperature increases, the solubility of a gas in a liquid decreases. So that's it. So now let's jump into my activity 5, factors affecting solubility but now in pressure. Liquids and solids exhibit practically no change of solubility with changes in pressure. Gases, as might be expected, increase in solubility with an increase in pressure. Henry's law states that the solubility of a gas in a liquid is directly proportional to the pressure of that gas above the surface of the solution. If the pressure is increased, the gas molecules are forced into the solution. Since this will best relieve the pressure that has been applied, the number of gas molecules is decreased. The number of gas molecules dissolved in solution has increased. So for the fifth activity, our material is any carbonated drink, so I choose Coca-Cola. So the first thing that we will do is to shake the carbonated soft drink. Then cautiously uncap the bottle. Then observe. So for my observation, all carbonated beverages are bottled under pressure to increase the carbon dioxide dissolved in the solution. When the bottle is opened, the pressure above the solution decreases. As a result, the solution effervesces and some of the carbon dioxide bubbles off. So for generalization, the higher the pressure above a liquid, the more gas that can be dissolved in that liquid. To a limit course, the solubility of gases depends on the pressure, and an increase in pressure increases the solubility, whereas a decrease in pressure decreases solubility. So that would be all, guys. Thank you for listening, and may God bless us all.